Welcome back to Sateesh Tech Talk. Today we are going to break down large language models or LLMs and understand how they are built from start to finish using simple real-world examples. Whether you are technical or not, the goal is to give you a clear picture of how modern AI systems actually work. Before we dive in, let's look at the big picture. Think of this as a roadmap for building an LLM. It all starts with data. Everything a model knows comes from data. That data is cleaned and prepared and then converted into numbers through a process called tokenization. Next comes the core step, training powerful transformer models using massive compute. After that, the model is fine-tuned and aligned to make it useful, safe and relevant. Finally, the model is tested, validated and deployed into real-world applications through APIs. The key idea to remember is this: every step builds on the previous one. Better data leads to better models and better alignment leads to better user experience. Keep this flow in mind as we go deeper into each step. To build an LLM, everything begins with data, and I mean a massive amount of it. Imagine feeding the model content from books, websites, software documentation, research papers, and human-created examples. This variety helps the model learn how people express ideas across different tones, subjects, and writing styles. The richer the data, the more flexible and knowledgeable the model becomes. In this step, the focus is on cleaning and preparing the data. Raw data is messy. It contains duplicates, broken text, spam, and sometimes even harmful content. So teams build automated pipelines to clean it up, removing low quality content, fixing formatting, detecting languages, and filtering it out inappropriate material. This step matters because the model learns from what it sees. Clean data equals a cleaner, safer, and more accurate model. Next comes the tokenization step. This is where things start to become mathematical. Computers can't understand words, so we break text into smaller units called tokens and convert those tokens into numbers. Think of it like translating a language into a code the computer understands. Sometimes entire words become tokens and sometimes words are broken into pieces, especially for rare or complex terms. These numbers are what the model actually learns from. Next comes the neural network training step, which is the heart of an LLM, the training phase. Here, the model uses a special architecture called transformer, which allows it to pay attention to relevant words in a sentence, even those far apart. During training, the model predicts missing words, evaluates how wrong it was, and updates itself. It repeats this process billions of times. This is where the model starts gaining true language understanding. Before we go to the next step, let's take a closer look at the transformer architecture, the engine that powers modern AI. On the left, we start with input tokens combined with positional information so the model understands order. The center shows the key steps: self-attention, which lets the model determine which words influence each other; feed-forward networks, which transform those representations; layer normalization and residual connections, which stabilize training. This design allows transformers to scale extremely well and understand language with incredible depth. Next comes the compute and scale step. Training an LLM is extremely resource intensive. We are talking about hundreds or thousands of GPUs working together for weeks at a time. To make this possible, teams use techniques like data parallelism and model parallelism, dividing the work across machines. This step is one of the main reasons LLMs are so expensive to build. Next comes the fine-tuning and alignment. Once the base model is trained, we don't stop there. We fine-tune it using supervised examples and we align it using human feedback. This is where the model learns to follow instructions, stay on topic, and provide helpful, safe responses. Techniques like reinforcement learning from human feedback or RLHF play a big role here. Next comes the validation step. Teams evaluate not just accuracy but also how well the model can reason and handle edge cases, situations it hasn't seen before. They also run red team testing, intentionally trying to break the system to uncover failures, biases, or harmful outputs. Because at this stage, it is not just about building a powerful model. It's about ensuring it's safe, reliable, and responsible. The final step in building a large language model is deployment. Once the model passes all safety and quality checks, it's ready to go live. It's hosted on scalable infrastructure and made accessible through APIs, powering apps, websites, copilots, and chat interfaces. To make it efficient, techniques like quantization are applied to reduce cost and improve response speed. And this is the moment everything comes together, when the model moves from development into the real world, ready to be used by millions of people. Now look at the end-to-end model creation summary, the entire LLM creation pipeline in one simple flow. From data collection all the way to deployment, each step builds on the last. If any stage is skipped or poorly designed, the final model will suffer. Understanding this flow helps you appreciate both the sophistication and the engineering excellence behind modern AI. Thank you for watching Sateesh Tech Talk. I hope this session gave you a clear understanding of how large language models are created from start to finish. I truly appreciate your time and interest in learning. If you found this helpful, don't forget to like, share, and subscribe for more tech talks and learning content. I look forward to seeing you all in the next session. Until then, keep learning and stay curious.